Good morning, students. Today I'm going to go over 5.5 classifying two-dimensional figures part 2, and this one has to do with triangles. So now, as I spoke about attributes in my last video, I will also talk about the same attributes in this video. Now, these are still polygons, right? Because they have many sides, polygons. But we're talking about triangles, okay? So, triangles. Tri means 3. Triangles, 3. So 3-sided. And of course, angles, right? So now, there's 2 ways to classify a triangle. You can do it by angles, or you can do it by sides. Okay? So now you have a right triangle. A right triangle just means that it has a right side. Now, when you classify a triangle by angles, now it means that you look at the biggest angle in the triangle to classify it. So in this case, the biggest angle in this triangle will be the right angle. And then this makes this one an acute and this one another acute. So you have one right angle and then you have 2 acute angles. Now, in total, the angles for a triangle should equal to 180, okay? So now you have an obtuse triangle. Now, an obtuse triangle will tell you that the biggest angle should be an obtuse. Remember, obtuse, caboose, obtuse, caboose. So caboose means it's big, it's huge, right? So the biggest angle in this is an obtuse, and then that means that the other angles will be acute triangles. All right. So now, the last one is a acute triangle. Now that means that all angles in this triangle are acute. A very common one is that each angle is 60 degrees. 60 times 3 would give you 180, so it gives you the complete angle for a triangle. All right, so now, sides. Now, the most popular one and easiest to remember is the equilateral. Equal, equi, right? It means equal. And again, lateral means sides. So that means that all the sides are equal. Now, these are not drawn to scale because I am not a professional artist, but I will try my best. Now, if you remember in class, I told you that if it has those tally marks and they all have the same one, so in this case, each side has 1 tally mark, that means that all the sides are equal, okay? So equilateral, 3 equal sides. All right, isosceles. So we're gonna go down our scale. So this one has 3 equal sides and isosceles has 2 equal sides. All right, and again, these might not be drawn to scale, but I'm gonna try. So since we have 2 different measurements, you'll have 2 different types of the tally marks on there. So you have this one and this one that are equal, and this one is not. So that's why this one goes up to the next level and it has 2. This one has 2 equal sides. Two equal sides. And now, scaling. I always call scaling the weird one, but it's very unique because all its sides are different. So it has no equal sides. Okay, so then it would have different Okay, so if you see one side has 1, the other one has 2, and then this one has 3. So that tells you that it has no equal sides, okay? Now, these are also polygons because it has more than 2 sides. So this one has 3. And then, of course, we covered our quadrilaterals in the previous video. All right. One thing is that an acute triangle can have those 3 equal angles, right? Remember I said I could have 60, 60, and 60, and that'll make it that 180. So if all the angles are equal, then that means that the sides are equal. So then that'll be an equilateral and also an acute triangle. All right. Now, you have to remember that an equilateral can also be an isosceles because it already covers those 2 sides. I'm sorry. Those 2 sides that it needs. All right. So an equilateral can also be an isosceles, but an isosceles cannot be an equilateral. Why not? Well, an isosceles does not have the 3 sides that it needs to be an equilateral. It only has 2, but the equilateral already has the 2, so that's why it can be an isosceles. All right. The same thing with an obtuse. An obtuse can have 1 angle, right? That is not equal, but it can have the 2 equal acute angles, so it can be an isosceles. That's not always the case. You just gotta make sure that you look at your little marks on the sides. All right, and this concludes the second part of our classifying 2-dimensional figures. Thank you for joining. Bye.